Hi, good morning. Today I am going to show you how the stepper motor is been running with the help of microcontroller ARM07 board. This is an interfacing experiment. It's an hardware related experiment where you are going to run your program using Keel Microvision software. Using this software, I am going to run a program, and this program is going written in embedded C. See here, for this you need two softwares. One is Keel Microvision version 4, that's what I am going to use for my lab, and the other one here is Flash Magic. So using these two softwares, I am going to run this stepper motor. For this program to be executed, you need set of hardware components, and all these hardware components are being shown by my co-staff.
First day lab programs hardware parts. Lab is my microcontroller and embedded system. First I am showing all the equipments what we are using here. This is microcontroller board. Okay, this is RS32 cable. This RS32 cable we are using. See here, CPU one port is there. This is VZ cable. No, this VZ cable upside is there. This is port we are using RS32 cable. Okay, next this is stepper motor. This stepper motor is connecting to this socket. See, once again I am showing how to see this socket. You have to see already this notch is there. We have to keep like this stepper motor, first stepper motor. Next we are using, this is power supply. Power supply we are giving, one is switchboard, this going to switchboard, another is there. See, we have to giving here system power supply is there. We have to fix this one. Okay, this is the hardware connections. Then next we are using how to go where Flash Magic is there. This one, this system Flash Magic is there. We have to click, double click, Flash Magic will come. See here 5 steps is there. Step 1 communication, step 2 erase, step 3 hex of file, step 4 is options, step 5 is start. See, first we have to select step 1. In step 1, select device is there. Here we have to go RM is there first. Then it will go, we have to go LPC 2148. Okay, we have to select OK, it will come. Then COM port is there. Here COM port we have to select COM1. COM1 how we will select means this RS32 cable is there, no? System to this one. This is COM1. Another also COM1, COM3, COM4 is there. We don't want. This is what we are selecting, this RS32. This is COM1. Okay. Next, baud rate.
The software part, that is what I am going to show, such that the program gets executed and you are going to see that the stepper motor is going to be rotated in clockwise as well as anti-clockwise direction. Right, I'll show you the steps for execution. So firstly you need to open this Keel software by double clicking on the app and the icon, and then you need to start with a new project. Right, in the Keel software, go with the project, a new project, and here for a better usage you need to create one new folder. So the new folder can be named as what you want. So I'll write it as EXPT is a new folder, and in this folder, okay, you need to type your program STEP. This is what the name of the file. So here you need to save it, and it is going to ask which is the IC that is what you want to use. So I'll take LPC 2148. Click on that and then press OK, and here it is going to ask for a startup.s file which is needed for your project. So hence you just click it as yes. So once your window is ready, so from here what you need to do is you need to type your program. So typing your program here is open a new file. So for this you can use Control N, or else just click on this icon, and here this is what an editor where you can write your program. So now this program will be in the embedded C format. So embedded C is a language that is being just used for your program execution. So instead of typing, just to save the time, I am taking the copy of that program and I am pasting here. I just pasted, and once the program is ready for execution, what you need to do is you need to save your program. So saving your program here is give the name of the program with an extension as .c. So this file will be stored in the folder, that is what I had just created. then save your program. Once your program file is been stored, saved, the font color of this program that you have typed gets changed. So that means this file is now ready for execution. So once your program is ready, edited, now what you need to do is you need to add this program to your target or else to the source program. So hence what you need to do is just click on the source group 1 and from here select add existing files to group source. And which is the file that is what supposed to be added? That is step C. So C is an embedded C program, that is what I already told you. Step C is a program that is supposed to be added, and then just close it. Now here step C will be just added in this source group 1. Once the hex file is been created, it will be displayed under this target 1 under this step C. So step C is your source file, and then lpc21xx.h is your hexadecimal file. So once hexadecimal file is been developed, the next thing that you need to do is to go to the Flash Magic. Open your Flash Magic, and from here you need to make certain changes or also select certain options. So for this, the step 1 here is communications. So under this select device, so which is the device that you want to use, that is what already it is LPC2148, that is what we had selected. And next is the common port. So which common port you are going to be selected, either 1 or 2 or 3, okay. So whichever the common port that is being enabled in your PC, you need to select. For my PC, it is enabled as COM port 1. So hence I select this as COM 1. Next is baud rate is 19200. It is data transfer, it is signal transfer rate. Okay? And then interface is non-ISP, and then oscillator you need to select it as 12 megahertz. And after this, the next step that you need to do here is erase flash plus code from the port, or else erase blocks used by hexa files. You need to enable the second one. Okay. So already the previous program, whichever thing that is available, that gets erased, and fresh hex file will be get loaded into this. So for this, into the Flash Magic, you need to bring the hex file. So my hex file that was created was stmt dot my hex file that was being created was step.hex step.hex hex. So just open this file, and then after that just enable the verify after programming, and then you need to start. Right, step.c is a file that is been added to the source group 1. So once your program is been written here, only thing here is you need to debug, you need to find the errors in the program. So for finding the errors in the program, what you need to do is you need to just build your program, or else just click F7. So once your program is been built, if any errors are been available, it shows that there are certain errors. If there are no errors, it is going to show that 0 errors and then 0 warnings. So once your program is error free, the next thing that you need to do here is you need to go to, okay, so you need to bring your hexa file here such that it is a file that is going to be written onto your microcontroller kit. So that hexa file here is just browse, and then from your experiment folder get it into your Flash Magic just by clicking step.hex and then open. So once your program is available here, the next thing that you need to do is just start. So now your program is getting written into your IC, into your microcontroller kit, and then your program starts executing. So that means your stepper motor is under rotation in clockwise as well as in anti-clockwise direction. You can just see the rotations. Since I had given the delay, it is rotating a little bit quickly. So both clockwise as well as anti-clockwise it is going to be rotated. So the total number of the steps that are supposed to be rotated, you can just design it in your program, and the speed of your rotation can also be controlled using your program. So I just stopped the execution of my program.
Now 19200. This interface is non-ISP. Okay, leave it. Oscillator megahertz is there. We have to write it 12 megahertz. Okay. Then step 2, we have to select erase blocks used by hexa files. Third step, in hexa file, we have already stored in, first we have to program executed, that is STM hexa file we have to store, and then here we have to browse it. Afterwards browsing, then verify after programming, you have to click it then. Next, see here, start, it will come, I will show you. Browse it, open this file, select, start now. See here, stepper motor, the motor will run clockwise and anti-clockwise. Okay, this is the program hardware stepper motor. Then how to we will stop means, see here file is there, ISP is there, option, tools, help is there. We have to select ISP. Then here erase flash is there, we have to select there, erase blocks used by hexa file. Okay, have to select, erase it, then OK, had to complete. See, total program is completed. Okay, thank you.
Okay, in this video you have seen how to rotate the stepper motor in clockwise as well as in anti-clockwise direction. So this is a program that is being used for demonstrating how the Keil software is being used along with the FlashMagick, and how the how the program is being executed using the hardware components. Okay, thank you.